And so on page 34, I had to extend my line a little bit to use this ruler. But we have an average of 250, and this would be the weight of the bags in grams. Okay, so you put that in there. The highest is right here. And I will just go, what is the standard deviation? Very easy number. So this one should not take you very long. Okay. And so a couple of questions. Can you have more than 3 standard deviations to either side? Yes. In fact, there might be a graph down the road. You take stats in university or college, and there'll be 4 to either side. That's fine. Okay. But for the most part, most graphs will just show you 3 because that comprises most of our data is going to be found in there. And so for your curve, just make sure it looks decent, it looks symmetrical, and you've got the percentages in between. If I ask you for it, if you're just graphing this for reference, for your own, to help you out, I don't really care how it looks, okay? But make sure you have these percentages and you have this on your study sheet. This 0.15 here, same here, 13.5. Make sure you tell me if I make a mistake, because if I go a little faster, things happen, right? And z-scores, if I ask you for them. And what do z-scores tell us again? The number of standard deviations above or below the mean that the value is located. So for example, the average is 250. If you were to use my formula and calculate the z-score, you would get 0 for it. You would, right? X minus x mean, right? Minus mean divided by standard deviation, you would get 0 for it. And so if something has a z-score of plus 1.5, that means that the value along the x-axis is 1.5 standard deviations above the mean. If it's negative 1.5, you know that you're 1.5 standard deviations below the mean. Okay. So and by the way, there could be values anywhere in between. This graph just shows the ones that land right at a z-score, basically, or at a standard deviation. What else do I need to say? I think that's good. If I tell you use technology, that's a hint, don't use your graph. Okay? Most of the time I won't ask you to graph if I want you to use technology. Calculate the probability of the bags weighing between. So what would this be? Normalcdf or inverse norm? Normalcdf. If it's asking for probability or percentage, you want to be using this. And this one is 232, 273. It gives me the start and the stop, and you got to go mean and standard deviation. If you do that right, I actually on my key, you probably saw me doing this, right? I take whatever I get here, multiply by 100, and that's 11.51%. So 11.51% of bags give you that. I'm on the wrong page. Oops. Not the right answer, right? I'm just looking, I'm like 232 to 273, that's like that's more than that. And my bad, that's why the graph is there. This is 99.98%, my bad. Don't give me a thumbs down just because I'm human, okay? Okay, percentage of bags heavier than 257, heavier than, or right, at least 257. Can you write this down? At least 257 grams. I'm going to start using that kind of wording. At least, at most. Okay? It's at least. So here, because it's asking for percentage, we use Normalcdf. We start at 257, and we use a really big number, correct? What's a big number, Mr. Dirksen? I don't know. Just keep adding zeros, and then followed by mean and standard deviation. times 100. That gives you 8.08%, okay, of bags would be expected to weigh 257 or more. Bags weighing less than 243, less than, so in this case, less than, so you're coming from the left, so if this is your bell curve, 243 is right about, that's why I want you to graph this to have an idea. 243 is right about there. So you're thinking you want all of this, okay? So we're going to go minus 1 million, and then you're going to go 243.5. That's this marker right here, 243.5. Followed by mean and the standard deviation. So normal CDF needs all three. Multiply that by 100, you get 9.68%. Okay? 9.68% of bags. Here's another good one. This is going to take it to the next level here. This one right here. The company disposes, right, gets rid of any bags that weigh less than 239 and any bags that weigh more than 262. What percentage of bags would the company dispose of? And if you looked at my key, I'm going to ask you to sketch this if you didn't do this, if you didn't look at my key. 239 is somewhere here. Look at the original that I made, right? 239 is somewhere here. Anything less than that is going to be discarded. So we want this section here. We want the percentage less than 239. Anything more than 262, that's about right here. That's also discarded. That's bad, right? We're going to get rid of that. Which means that these ones are good in here. Like anything between is good. They're going to let it go. But if it's less than 239, why do you think they would get rid of them? They get sued, right? Somebody's going to sue you. Maybe. Most likely, right? If they find out that the bag is it doesn't have enough chips in it. If it's too heavy, then the company's losing, right? So that's the reason why. So you need to figure out these tails here. There's a couple of ways to do it. Okay, so I will do it this way. 1 minus the good bags. Because the whole curve is 1. I'm going to go 1 minus normal CDF 239, 262, 255. This is 1 minus 0.9778 something. That leaves you with 0.0221. Multiply it by 100, that's 2.21%. You coming after lunch?
Yeah, we're just trying to figure out, I just came in. Is it left or right? It's left, right? Sorry, it's the left side we're putting the cable to, right?
This side, because I have.
Well, one of those is going next year. So we're setting up in preparation for next year where you'll have one of those.
Okay.
So either we can set it up on this side and that's for your devices next year, or that side. Yeah.
Okay.
Devices. Well, think about it for next time there. Either
Okay.
way, I'm bringing a 50-foot.
Okay, sounds good. All right. Just the tech guys finally installing the projector up there. So 2.21% will be discarded. Another way of having done this is, yes, you could have done a normal CDF to figure out what this is, another normal CDF figuring out what this is, and then add them up, that's up to you. That's a lot of normal CDF, if you ask me, right? So this is a shortcut here. So basically, I will just, if you want to highlight this part, I'm taking that away from 1. Right? So if I take that away from 1, then I'm left with the ones that are discarded. So it's a bit of indirect reasoning. I'm also going to tell you that this is the total under curve. Okay, if you're writing this down, then that's why I did that. Okay. So this is percentage. If the question asks for, if you go to the next page here, it asks for if the company produces a certain number of bags per day, how many bags would we remove from the production line? So you go 0. Pay attention, okay? 221, right? We take that answer we got on the previous page, turn it into a decimal, we multiply that by 5,400, and you get 119.34, but you can't have that because we're talking number of bags, so it's approximately 119 bags. If you go 120, that's fine, as long as you have a whole number there, okay? Next, what percentage of bags have a weight with a z-score between this and this? What is the mean and what is the standard deviation when you're talking z-scores? The mean is 0, standard deviation is 1. Because z-score, if you look at the graph here, if you look at the graph, the mean has a z-score of 0. And how much am I going up by? 1. 0 and 1. So we're going to go normal CDF. We're going to go between 0.6 and 1.34. 0, 1, like that. Okay? And you're going to get, if you multiply this by 100 already, your final answer is 63.56%. Okay? You should know where this is on the bell curve. You should know exactly because, right, if this is 0 and it's 1, 2, 3, 1, 2, 3, negative 0.6 is right about there. This is negative 0.6. And 1.34 is right about there. That's 1.34. So you're wanting the percentage in between those two values. Okay. Calculate the actual weights that correspond to each z-score above. Would the percentage of bags between these be the same? What do you think? If I actually find out what negative 0.6 is in grams, and I find out what 1.34 is in grams, and I do a normal CDF, I should get the same answer. I have to get the same answer. Okay, so here it is. A z-score of negative 0.6. If you want the actual value, sorry, not x bar, but it's x is z times standard deviation plus the average. So we're going to go negative 0.6. Your standard deviation is, what is it here? In this question, the standard deviation was 5, correct? And the average is 250. If you plug that into your calculator and you're careful, you're going to get 247 grams exactly. If you do this exact same score with the exact same work with a z-score of 1.34, it's simply plug in and go. Plug this in, you get 256.7 grams. So each z-score has an actual value associated with it within the context. Okay? So just complete aside. When it comes to height, what is my z-score going to be? Just guess. I'm average? 2? Probably closer to 3. Like Sisler, I'm probably on the 3. Like I'm like, there aren't that many teachers taller than me or people taller than me. I mean, there might be, but you know what? But you see what I'm saying? Like that's what z-scores. If someone says someone's test score puts them at a z-score of 3, you're like, oh, above average. Whoa, way above average, like top, right? If your z-score is -3, Zia later, right? Zia next year, right? I'm just kidding. Okay, the company would like to know the weight. Oh, I'm not done yet. Whoa, wait. I got sidetracked. I shouldn't have. Okay, back to this. If I were to go 247 to 256.7, now I have to use the mean and the standard deviation of the question, because I'm not using z-scores, I'm using the actual weights, right? I'm going to zoom into that. I'm just going to give you the answer. You're going to get the same answer. I don't have that on my key for some reason. You still know how to get it, right? %63.56%, exactly the same as before. So whether you use the z-scores or you want the actual scores, you're going to get the same percentage under the curve. Okay, you got to understand that every score has a z-score and every z-score has a score that associates with it. Okay? Okay, the company would like to know the weight, not the percentage, the weight that would place 65% of the bags produced below this weight. What are you using here? Normalcdf or inverse norm? Inverse norm, because it's not asking for percentage, it's asking for the weight. So watch this. I think you should always make a little bell curve. And so where is this line that I'm trying to find? I need 65% of the bags produced to be below this weight. You should think of it this way. It has to be here. It has to be further over the mean towards the right, because that would put 65% of bags below it. And how many are above it? Percentage-wise, 35 are above it. But this is the one inverse norm needs, the one below. So you go inverse norm, turn it into a decimal, and then just go 250 and 5. You just need 3 entries for inverse norm, and you're going to get 251.93 grams. Okay, so a bag that has 251.93 grams is positioned in such a way that 65% of bags weigh less and 35% of bags weigh more. Okay, so that's how you do that. Another couple, then you're on your own. The company would like to know at what weight, not percentage, would 6% of the bags produced be heavier than it. So translate this for yourselves. What weight would have 6% of bags produced be heavier than it? Again, this one the line would have to be further up the x-axis, because then you have 6% weighing more and therefore 94% of bags weighing less. This is what inverse norm needs. Okay, so I went 100 minus 6 to get that 94. So this would be a 2-mark question, by the way. If you need to figure out the percentage to the left, it's a 2-mark question. So that's another giveaway. 0.94, 250, 5. You figure that out, that is 257.77 grams. Almost done. I need to do the bottom of 36 yet, so always left. If you were to put in 6, okay, inverse norm thinks this. Inverse norm thinks you're trying to find a weight where 6% are below it. So this is not right. You got to interpret it. Is it giving me the left or the right? Once you figure that out, if they give you the right, you have to figure out the left. And that's what goes in here. Very important. Always the left, okay? Think of Beyonce's song, then you'll be fine. All right. She didn't pay me to say this. Determine the z-score of a bag that is heavier than 55% of the bags produced. The z-score of a bag that's heavier than 55. Okay. A bag that's heavier than 55% would be somewhere just over half, right here. This bag would be heavier than 55% of the bags that have been produced. Did my key do it the opposite way? I think my key is wrong. Did my key do it the opposite? If you check the key, I think. So, but you want the z-score of a bag that's heavier than 55%, so this is correct. So that's my bad. I'm looking at my key, it's wrong. So this is what it wants. It wants the z-score. How would you do that? 2 ways of doing that. Inverse norm. Write this down if you don't have both methods. I think it's good to have both methods. Method 1 would be inverse norm. I'm going to give you the easier method here. 0.55. The mean is 0. Standard deviation is 1. Why am I using 0 and 1? Because that is for a z-score, the mean is 0, the standard deviation is 1. So that would be, I have to do this because I got my key wrong, 0.5501. And that's 0.13 as the z-score. Okay, that's the easiest way to do it. Method 2 is using inverse norm. We use 0.55. You're going to use 250 and 5. That's 250.63 grams. But that's not a z-score, is it? That is the actual weight. Do you know the formula for z-score to convert this to a z-score? Yes, we do. Z-score would be 250.63 minus the mean divided by standard deviation. This is just to show you that everything is connected. Okay? And that's 0.63 divided by 5. That is 0.13. So you either realize right away, oh, we're talking z-score, mean is 0, standard deviation is 1. Or if you miss it, you figure out the actual weight, use the formula to do it. Which one is easier? I would say method 1, hands down, the easier one, but that's up to you. Let's go to 36. I'm almost done, sorry. I needed to do one more go at it to make sure we're all on the same page and to catch my own mistakes on my key, right? I'm gonna have to fix that. It even says can't use formula. You can't use the formula right off the top. That is true. But after you find the actual weight, yes. Determine the z-score of a bag that is lighter than 31% of the bags produced. So where would that percentage be? This bag is lighter than 31% of the bags produced.
Please get a custodian to the office. A custodian to the office, please.
Let's try something. Don't copy this down at first. I don't know if you did this. If you put it here and you say 31%, does that make sense? Right now you have the bag that is heavier than 31% of the bags produced. So that's not a good one. This is not good. Undo, undo, right? So try the other side here. If you have this weight and you say 31% here, now you're talking, right? Because this bag is lighter than 31% of the bags produced. Okay, so if this is 31, then this is 69 on the other side. And this is the weight we're after. Oh, we want the z-score, sorry. We want the z-score. So we're going to go inverse norm, 0.6901. I like this one. It's much faster. That's 0.5 exactly. 0.5 is the z-score, positive. So you got to make sure you go positive or negative. Okay? And it's going to require some practice, that's it. Determine the z-score of a bag that weighs this much. Just use your formula in this case. 259.25 minus 250 divided by 5. You get 9.25 over 5. That would be 1.85 positive. And what does that tell us? That a bag weighing 259.25 grams is 1.85 standard deviations above the mean. How about we write that down? Explain or meaning. A bag weighing 259.25 grams is 1.85 standard deviations above the mean. And this is the last one. I'm going to leave you with this. This one you should all write down. This will come up again and again. Okay? And it's worth 2 marks. You ready for this? Page 36. Make sure you write this down. I didn't teach you this, so if you tried it and you couldn't do it, that's fine. COVID symptoms last 7 days on average, with a standard deviation of 0.5 days, half a day. If the duration of the symptoms are or is normally distributed, right? A, the middle 80% of cases last between this and this many days. How would you do something like this? The answer is found in this little piece of information. The middle 80%. So what I want you to do is, if I don't give you a bell curve, make one. Sketch only. And you say that you kind of determine this is kind of like the middle, and you say that that in there is 80% worth of data points. 80% of cases are found in there. Okay? Which means how much are these tails gonna be worth then? If this is the middle 80, there's 20% left, right? So each side will be worth 10, there we go. So I'm gonna go 100 minus 80, that's 20. I will divide that by 2, that's 10%. So 10% goes in here, and 10% goes in here. So now you've got a lot more information. And so basically they want to know this value right here, call this x1, and they want to know this value right here. Like 80% of cases take this between this many days and that many days. Let's focus on x1. How can we find x1? We're not using Normalcdf, correct? Because we know the percentage. So we're using inverse norm. We're going to go inverse norm of, do we know the percentage to the left of this value here? It's 10%, correct? So let's plug that in. What's the mean? We know that. It's 7. Standard deviation is 0.5. Boom, we're going to get that answer. Let's do that in a little bit. Let's do the x2 now. x2. Do we know the percentage of data to the left of it? To the left of x2? 80 plus 10, so that's 90%, correct? Seven, 0.5. I will just show you here. I will use a red pen. How did I get this 0.9? I'm just going to say 0.1 plus 0.8 gave me that, right? And you do the math. I will just give you this already. 6.36 days, and the other one is 7.64 days. So use the symmetry of the normal curve to help you out here. So now you could just plug this in 6.36, 7.64. So now you know how to do something like that. Did I assign up to 36? Yeah? Okay. So I'm going to ask you to try, I think it's all the way to 39. 39 is a little bit of a head scratcher, but I'm still going to do it. And I hope you enjoy a little bit of class time. You can ask me questions. I kind of want you to get stuck sometimes, so you think, like, what should I ask for? All right? And